mechanisms, 5-HT2A and 2C agonism is known to lower dopamine in the mesolimbic pathway. So what we're hypothesizing is that these tug-of-war mechanisms result in the net effect of normalization or stabilization of dopamine above withdrawal but below reinforcement. So on to the physiology of addiction. The elevations in dopamine that we've been talking about in the mesolimbic pathway are associated with a phenomenon called synaptic plasticity. This is a process by which nerve cells, the communication and connections between nerve cells are altered or changed. And synaptic plasticity has been associated with the development and maintenance of addictive behavior. So release in dopamine in two parts of the mesolimbic pathway that we talked about, the ventral tegmental area and the nucleus accumbens, has been hypothesized to reorganize neuronal circuits leading to or reinforcing addictive behavior. And we know drugs of abuse acutely raise dopamine in both those areas. And this results in a change in neural architecture, and that's associated with conditioned and learned processes. So this process has been referred to as diabolical learning. These neuroplastic changes result in the activation of reward circuitry even when exposed to objectively neutral cues associated with addictive behavior. When I walk down the street, I don't get a dopamine push when I see a street corner. However, the heroin addict who walks by that same street and buys his heroin will get a little bit of a rush just walking by the corner. That's the diabolical learning that we're talking about. So according to Stahl, the reward pathway has been hijacked by the addiction process. And our physiological hypothesis is that ayahuasca facilitates adaptive synaptic plasticity by regulating dopamine levels and a bunch of other associated cascades in the mesolimbic pathway. Things like glutamate and GABA and metabotropic second messengers, transcription factors. There's a lot that goes on behind synaptic plasticity, but dopamine does play a large role, we know. So again, balance is important. High dopamine, reward circuit hijacking. Low dopamine, a diminished impetus for neuroplasticity. This adaptive plasticity that we're talking about would allow the learning of new behaviors and associations without hijacking the circuit. And it would also, interestingly, support the unlearning of addictive associations and cues by allowing the person who's under the influence of ayahuasca to experience these cues in the visionary state while being protected from the dopaminergic surge that would lead to reinforcement or pathological learning, diabolical learning. On to the psychology of ayahuasca. I'm going to pass it over to Mitch.